For lesson 2 of module 3, we're going to solve linear equations again, but this time it's going to have fractions in front of the variables, or fractional coefficients. And we're also going to talk about when a linear equation either has no solution or infinitely many solutions. Okay, so here we go. The first step is if there are fractions, we're going to multiply both sides by a common denominator to clear the fractions. So here's our first equation here, which is 2/3 y take away 4 is equal to 8. So notice how the only denominator in the equation is a 3. So I'm going to multiply everything through by a 3. 3 here, 3 there, and 3 there. So we're just multiplying everything by 3. But this is beautiful because 3 divided by 3 is just 1. So the 3's will divide out to be 1 and get 2y. Take away 3 times 4 is 12 is equal to 24. And then we just we do what we need to do as we did in lesson number 1. So I'm going to add 12 to both sides. So 2y is equal to 36. And then, of course, we're going to divide by 2 to get a 1 in front of the y. So y is equal to 18. All right, let's do another one. Okay, so let's take a look at this one. It's x over 5 is equal to 2x over 3 plus 7/15. So the first direction says to multiply everything through by a common denominator. Well, we have a denominator of 5, 3, and 15. So the common denominator would be 15. So I'm going to multiply both sides by 15. The one here, the 15 and the 5 will of course cancel. 5 goes into 5 once, 5 goes into 15 3 times, so we'll get 3x on the left-hand side. If we look here, 3 goes into 3 once, 3 goes into 15 5 times, and 2 times 5 is 10, so that'll be a 10x. And we love this piece because 15 divides out 15 and just gets 1, and we get 7 left. So now I'm going to subtract 10x from both sides. The reason why I subtracted 10x was I already had a constant on this side. I didn't want to have to move two things. These will add out. So I will get a negative 7x is equal to 7. I'm going to divide through by negative 7 because I need to get a positive 1 in front of the x. So x is equal to negative 1. Now let's look at part C here. We get 7x take away 4 is equal to 1/2 x plus 1. So I only have one denominator, so I'm going to multiply everything through by 2. I put the little parentheses in to kind of indicate we're multiplying here so I'm not messing up. So this is 14x, take away 8. The 2's will divide out and get 1, so x plus 1 times 2 is 2. Oh, okay, so we're going to take 1x here, we're going to take it away from both sides. So I get 13x, take away 8 is equal to 2. 13x, take away 8 equals 2. I'm going to add 8 to both sides. So I get 13x is equal to 10. And then I'm going to divide both sides by 13. So our result is x is equal to 10 over 13, which isn't bad, it just is a fraction. Okay, let's move on to the next page. Now we're going to talk about the types of solutions you can have when solving linear equations in one variable. You could have a unique solution, which is what we've been getting. x equals 7, okay? Or you could have no solution, in which case you're going to get a false statement like 9 equals 4. Or you can have an identity in which you get a statement that's always true, like 9 equals 9. In these last two, during the process of solving, the x's or the variables, doesn't matter what letter we use, will always add out of the equation. So let's take a look at part A here. So we get 2x plus 9, we're going to distribute, is equal to 2x plus 8. We're going to subtract 2x from both sides. And notice how these will add out, and I get 9 is equal to 8, which is false. So that means there's no solution to this equation. That means no matter what number I put in for x, I will never be able to find a number in which both sides of the equation are equal. Let's take a look at this second one. We get 2x plus 8. I'm going to distribute the 2x through 2x plus 8. So we're going to subtract 8 from both sides. So 2x is equal to 2x. I'm going to subtract the 2x from both sides. So we're going to get 0 equals 0, which is true. So this equation is an identity. And that means I can put any value I want in for these x values, and it will work with any x value I want. Let's move on to the next slide. Now we're going to solve some equations with variables in the denominator. You'll notice on 3a, there's two distinct denominators, 3 and x. So all we have to do is multiply both sides of the equation by 3x. So 3x, 3x, 3x. So if we look over on the left-hand side, the x's will divide out and get us 1. And 3 times 5 is 15. We're going to divide out the 3's and get 2x. Divide out the x's, and we get 21. Now I'm going to subtract 21 from both sides because I don't feel like moving two things. So I get a negative 6 is equal to 2x. Divide both sides by 2 because I have to get a coefficient of 1 in front of the x. So I get x is equal to negative 3. So let's take a look at 3b. Well, we're lucky on this one because 2x totally is the only denominator there. So we get negative 4. It's 1 over 2x minus 1. I just rewrote it so it will be a little bigger. I'm going to multiply everything through by 2x. So we're going to get, we want to make sure we multiply these two things together. 2x times a negative 4 is a negative 8x. Yay, these divide out and give me 1. And then if I multiply 2x times this negative 1, I'll get a negative 2x. I'm going to add 2x to both sides here. So I get a negative 6x is equal to 1. I'm going to divide by negative 6 on both sides because I need to get a 1 in front of the x. So x is equal to 1 over negative 6. In both of the solutions that we just did, they're unique, right? Good? Now just to recap, we did linear equations with fractional coefficients, and we cleared the fractions by multiplying both sides by a common denominator. Then we discovered that a linear equation can have a unique solution, no solution, or it could be an identity. In other words, you could put any value of x you want. And last but not least, we talked about equations with variables in the denominator. And then we would clear it the same way we would clear with just plain numbers. We multiply both sides by a common denominator. Good luck on your worksheet and your My Math Lab assignment.